Hello YouTube, iFixItAll here, Team iFixItAll. Got a 20th anniversary Mercury Cougar here, 1987 model with 375,000 miles on the clock. And it is since manufactured. What is this? Chicken parts on my car. It's had its first failure since it was manufactured. This is number 250 of 4,998, I believe, that were made. And it just basically features a lot of options that Ford was advertising to come over the next 20 years at the 87 Mercury and Ford trade show up in New York. So this, I've already determined the failure, but the purpose of this video is to show you the basic steps you got to go through to see what the heck is going on with your car when you're in a car cranks over but it just won't start condition. And it's pretty much the same for all vehicles, no matter what the age is. All right, so let's get you guys strapped into this little hokey bracket I have up here and hope this video turns out okay. Hang tight while I get you snapped in. So what does a 375,000 mile engine look like? Let's find out. It looks a lot like that. Pretty dusty. So let's move into troubleshooting. One of the first things I want to do is when you're troubleshooting, you have this condition of it cranks over but it doesn't start. You need three things. You need air, you need fuel, and you need spark. So this type of engine platform was some of the most simplest of electronic computer controlled platforms that Ford ever made, and it's very dependable, really kind of bulletproof, so to speak. The distributor system is unto itself to create spark. There is a communications back to the computer for things like pulse width modulation of the fuel injectors themselves. But as far as the ignition goes, it's not controlled by the computer in the car. This is, for all intents and purposes, this 87 vehicle shares a lot of the characteristics of a modern day car, but we don't have things like a body control module or CAN bus communications. None of that. It's really simple stuff like O2 sensor, throttle position sensor, MAP or mass airflow sensor, air charge temperature sensor. This doesn't even have a crank sensor. It uses a device inside the distributor to determine where cylinder number 1 is. And so, yeah, let's first check and see what we got, what the problem is. I've already made a determination what the issue is. I've already stated that, I think. I had to start this video like 4 times. But to recap, I already know what the problem is. It's not a fault that's easy. It's not the alternator. It's not the... But this is the first fault this 302 has had since the car was made. And if that's any testament to the dependability and reliability of, most importantly, reliability of some of the older, somewhat high-tech ingenuity that was being produced in the 70s and the 80s and the 90s. when everyone's wanting dependability with looks, I happen to like 83 to 88 Ford Thunderbirds and Mercury Cougars. So I own two 87 Cougars. My wife owns a 1970 Volkswagen Carmen Ghia. But it's all about taste. We don't have car payments, and we never have. And maybe if you're listening out there and you're thinking about looking for a car, maybe you should look for the one car you've always wanted, and then make it your destiny to love that car, to learn everything about that car you can, and also learn a strategy, have backup parts, have collect parts over time for it, so that when it breaks and the shops stop stocking parts for that car, you have your own stockpile like I do. Also, what's really nice is interchangeability. Most of the parts on this Mercury Cougar passenger car are interchangeable with my 1990 full-size Ford Bronco. And it's a V8, but it's a 351 cubic inch. This is a 302, but uses the same intake air bypass, uses the same throttle position sensor, the same ignition system, air charge temperature sensor. All the sensors and things are the same, so I can troubleshoot, pluck off one guy and put it on another. But first things first, let's check for spark. We're going to do spark. Let's do air first. All right, air. I need air. Shine a flashlight up in there. Open the throttle body. Yep, it's good and dirty like it's supposed to be. Next thing I'm going to do is check for spark. Looking for my spark tester, because I just sat it down. Once upon a time, this spark tester was brand new from Harbor Freight. It's just an extension of your spark plug wire. You just basically unplug a spark plug somewhere, and then plug this into the spark plug wire, and then plug this into the spark plug, and there's I think a halogen light bulb in there that will illuminate as you crank. So we're going to check and see if we have spark. Do we have a spark problem? Is our problem with no start related to, let me do this the other way. No, I can't. Can I? Yeah, I can do that. Let's see if our problem is due to a spark problem. I'm probably going to have to turn the light out over here, so you can see the light up. Just make it a little darker for you, so as I crank you can see that light strobing. Fuel pump kicked on. Well, looks like we got spark. Alrighty. I'm leaving this laying to the side right now, but this leads down to your spark plug, any random spark plug you have installed. So right now we know that the system that generates spark is doing its job. Do we know if we have fuel? Most vehicles have something on the fuel rail called a Schrader valve. It's like a test port. It looks like a tire, a thing where you add air to a car tire, but it's usually metal. It's on the fuel rails. If you look for your injector and find the injectors and find the main pipes that feed the injectors, you'll find a test port somewhere that is used to check pressure. There's a needle in the center, and if you can find something tiny to push into it, you'll see if you've brought fuel pressure up by turning the key forward on your inside the car. And I'm just dripping wet right now with fuel. And plus I can hear the fuel pump operating. And with this car I happen to know that the computer will, when you turn the key forward only, it'll run that fuel pump for about 1 or 2 seconds and then shut it off. It's priming the top side of each fuel injector, preparing for you to go to start. And you can hear it kick on and kick off. So what I want to do is during crank, I want to find out if I have the proper fuel pressure, because that could be a culprit too. So let me pause this and I'm going to hook up a fuel pressure gauge. Alrighty, I'm back. Double check and make sure I'm recording here. I believe I am. Let me just take a peek. Yep. Let's see it recording. Okay. Sorry for the bouncy there. So you've got to have some basic idea of what kind of tools you will need when you have an older vehicle and you want to keep it on the road and you learn everything about it. And you do have to spend a little bit of money on some of these extremely important tools when you troubleshoot. So I had a little $6 test light basically to test for spark. So that gave me information. I know it's highly unlikely that I have a spark issue. Do I have a fuel delivery issue? Well, I have a fuel pressure tester here. And you could price these out if you like at the various stores or online. But the very first thing you want to do with your fuel pressure tester is what I did. I'm going to start with the gauge, and I'm going to show you how long this hose is. The hose is still coming. It's still coming. And there's the end. What I did was I cut the hose right in the center when it was a few years ago. And the reason why I did this is because I ran across a shop in the shop manual for these cars, an instruction for the Ford Motor Company technician to, during troubleshooting fuel pressure situations, install your fuel pressure tester on the Schrader valve and drive the car with the fuel pressure gauge duct taped to the windshield, and observe the fuel pressure during acceleration and from a stop to a go scenario, to watch the fuel pressure to verify that it did not go below 20 pounds during shifts in between gears. So your fuel pressure is doing a variable, it's varying in fuel pressure during acceleration phases. And if you have trouble with bucking or something like that, you can determine if your fuel pump is getting weak by just simply modifying your fuel pressure tester just like this. Just cut it and splice it, clamp it, and you extend it. And now this one is long enough to reach my windshield. We're going to see what our fuel pressure is, so I'm going to screw this into the Schrader valve. And I'll zoom you guys in so we can all hopefully see it increase in pressure. This fuel pressure tester might set you back $50, I think. Something to that effect. Maybe more, maybe less. All I'm looking for is that needle to come up around 40. I'm going to cycle the key a few times. And I'm going to try to zoom you in on that. Repoint you. There we go. I kind of wish I could do better. There we go. That'll be good enough for what we're doing. So I'm looking for the needle to end up right in this area, right around 40 psi, just by turning the key on and off a couple of times. I've got this stupid battery charger in my way. Dang it. I gotta do something about that. Go under it. Alright, cycling the key. And I'll do it a couple, 3 times. I have a connection issue over there, evidently. Oh, is it starting to build? Yeah, it's starting to come up. Could crank it, but I just don't want to run the battery down. Oh, I hear pressure building now. Oh yeah, it's getting up there. I'm going to bump it over a little bit. Yeah, that got us up to where I was talking about. It's around 40. Yep. So it looks like we got fuel pressure. So with that being said, we've eliminated spark and fuel and air. Something else is going on here. Let me zoom us back out again. All right. Now I've got to get a rag to catch that fuel that's stuck in the hose now. That's what this guy is for. I'm going to hit this relief valve and it's going to catch the fuel. Alright, got that. I'll unscrew this from the Schrader valve. Now there's a significant amount of gasoline still in this hose. So what you want to do is push your button in with this thing aimed at the ground until you see no more fuel come out, because you don't want to store your fuel pressure tester with fuel in the hose. So that's what I'm doing over here. I'm just going to let it run right into my dispenser canister. And it's about done. I can do that later. take away from the video. All right, so hang on. Let me pause it. Let me get geared up for the next thing we got to test. Alrighty, so now that I've checked for my fuel, air, and spark, now I'm kind of concerned on what is the issue here. So I bumped the camera. Sorry about that, guys. I think I threw it all out of whack too. So now I'm concerned with what's going on. So I've got air, I've got spark, and I've got fuel and no start. Is it timing right? I happen to know this is my #1 spark plug post. So what I'm going to do is I'm going to use a tool that you can get at Harbor Freight pretty cheap. But it's one of these. It's just a remote start switch. A couple of gator clips on it. And the objective is to get my rotor button on the distributor turned around, getting close to the #1 spark plug post. You don't have to own one of these. You could use a screwdriver to jump across your starter relay posts. I'll demonstrate that. It makes a lot of sparks though, but it can be done. You see? But instead of shorting out the starter relay, which isn't shorting it out, it's just jumping across the contacts to force power down to the starter. This tool here, it gives you the ability to be mobile around different areas. It's doing the same thing as a screwdriver. And one of the leads is supposed to hook up to here. And the other one goes to the positive battery terminal. That's my S terminal. Turn the key forward. Yep, it's working. What I'm attempting to do now, without destroying anything, is to make sure my cables are clear from all these rotating parts. I think I want to go this way, and for the sake of safety, go underneath this. There we go. That way when I pull the trigger. Okay. So I'm targeting the distributor cap. This is my #1 spark plug post. I want to bump the engine until the rotor button is getting close to that. And then what I want to do is turn the crankshaft with a socket and a ratchet to get my engine on top dead center. And then pull #1 spark plug and see if the piston is at top dead center or not. So, if I just imagine looking down on the distributor where my rotor button is pointing, it's past that point. I'm going to make a mark on the dizzy just to mark #1 location with a Sharpie. I'm going to try to get right in there. right in this general vicinity. I accidentally made a second mark I don't want. Get rid of that one. Let's see what we got here. Let's see if that's close enough. I need a light in the back pocket. Actually, that's pretty close. Okay. I'm going to crank the engine over until the rotor button starts coming toward this direction. You'll see it rotate. But this also tells me something else. Is my rotor button rotating? You know? That tells me a lot of things about the mechanical stuff. That's pretty damn close right there. In that current state right now, I'm at top dead center, and my timing marks should be within view. And if I look down in here, I'm way out of whack. Matter of fact, I would say just for checking time, I'm pointed right at number 1 spark plug post. I'm a little bit off. I think we just found a problem. I'm going to take you guys down here and show you this. I hope I can do this right. Let me pause. Alright, so I got me a shop light hooked up, and this is number 1 spark plug post. Get you get your light set up here. It's probably right there. Sort of like at that angle. And if we peek underneath, you'll see the rotor button is pointed right where it needs to be. Right back there, you'll see the little brass piece where the rotor button's pointed at. That's pointed right on number 1 top dead center. That's pointed on number 1 cylinder. My piston should be all the way at the tippy top right now in its hole. But more importantly, my timing marks should be locked in dead nuts right close to top dead center. So hang on and I'll show you something else. Alright, I'm going to get you guys in this little crevasse down in here and let you actually see the timing mark orientation and the going-ons here. I hope I don't mess this up. Okay. I'm going to zoom in. You'll see a metal pointer, and then you got 2 main paint marks. One's yellow and one's white. Let me get something to point with. Okay, I'm back, and I got something to point with. But you can see a metal pointer right here. I'm getting down there. This guy, that's a pointer. Then way up there, you'll see a yellow and a white mark. The yellow mark is top dead center for number 1 piston. It should be pretty damn close to this pointer right here. And it's not. It's way up there. That white mark is 10 degrees before top dead center, which is what a lot of 302 people set their cars to. Or that's what the manual calls for, the white mark. That's 10 degrees before top dead center right there. And that's 0 top dead center. Now I see that my distributor cap was telling us the rotor button is pointed right at spark plug number 1. That my yellow mark should be down in this area somewhere, closer to the pointer. So what that tells me is my engine has jumped time. Jumped time. What do I mean by that? Well, there is, on the crankshaft, there's a gear in the engine that connects to a gear on the camshaft. And the gear on the crank is small and the gear on the cam is large. I think it's like a 4-to-1. As the crank turns, a chain turns the camshaft. The camshaft operates the valves and times them so that you have the proper compression ratio to ignite your fuel. So your piston is down, or no, the piston goes down and sucks air and fuel in, and then the piston comes back up and compresses the fuel. And then spark happens at 10 degrees before top dead center. And that explosion pushes the piston back down. And then the next stroke up is the piston pushing the exhaust out. So there's actually 4 strokes to get work done on each cylinder. So when this failed on me is when I was getting in the car to go to a little corner store. I was starting the engine up and it wouldn't crank. And I thought I heard a noise, but I just wrote it off as nothing. But as I cranked, I'm like, no, that was something. So what's happened is, due to wear and tear, that chain has developed a lot of slack in it. And the crank just skipped a tooth or two. Because right now, my timing marks aren't where they're supposed to be. So let's verify that. If I'm out of time, then my compression number should be low. Extremely low. Let's test a couple of cylinders and verify. Hang on. Okay, so here's another tool you should have, is a compression tester. These things will set you back a little bit of money. They're about 50, 60 bucks. But I'm going to check compression on cylinder number 1. I've taken the spark plug out, so I can take my gauge off. I think it's a good idea to put a little bit of oil or something on these threads. As you're using the compression tester, you want to keep on adding oil to your threads and and a trick I do is right in here, I add an O-ring that's a little thicker than what comes factory because it just tends to seal better. And I'm just using a regular old mix of some homemade brew motor oil. And I'll just put a little bit of oil right on the threads just to, when I screw it in, it'll air seal up a little bit better. So I'm going to thread this in to where spark plug number 1 was. And now if our theory is correct, I will have low compression. Well, what is good compression? You can Google it, but you want about 120 to 150 pounds. But the right answer is you want to have even compression on all your cylinders. Let's say what I just said was relating to the troubleshooting. I'm looking for, if I'm right and my timing chain jumped, then I'm expecting low compression. But if this motor were up and running and I was just spot checking, I would, sometimes these things are hard to get in. If I was spot checking all the cylinders to check the condition of my motor, I would want, let's say 150 is my target. I don't want to have too much deviation around 150. The book, shop manuals give you a lot of leniency. They'll tell you plus or minus 10% across all the cylinders. Yeah, with a cold motor that's not lubricated and has oil slung all over it, maybe that's true. But for a warm motor, if you're getting 150 on one cylinder and it's like 146 or 7 on another, then 152 on another, and 148 on another, you know, you're close enough. But if you've got like 150, 150, 125, that's a big deal. But let me try to get this screwed in first. I won't take up video time for this again on the next one. We're going to spot check several. Let me pause this. Hang on. All right, I'm back. I'm going to hook up my gauge, but there's a close-up of the gauge. And you're looking for numbers like in the 120 to 150 range on a normal motor. You want to be, if you've got 150 in one place and 120 in another, it's time to start looking at things closer. Even if your engine's not broken, you know you've got a foul ball there somewhere, whether it be head gasket or something else. But in this case, since I know my timing is off, I know my valves are now not opening and closing in the proper moments when they're supposed to be, so therefore I should have low compression. So I'll snap this in, and all this is a one-way check valve with a gauge. So it allows air to shoot into this and stay trapped so that you can read the gauge. I'm going to crank the engine with my remote cranker there. And I guess I should turn the ignition key off. Hang on. I don't really need to have the ignition on during this. And that should have lowered my amp draw on my charger. Let's make sure I'm clear. I don't want to spill my oil anywhere. Okay, so I'm clear. And let's see if I can zoom you in on this. All right. I think I better snap the distributor cap down too. When you're working on engines and you're dealing with rotating the crank around several times, you gotta almost start thinking about safety big time, because what did you leave laying in the bay that could fall in and fling up and hit you in the face? This, if I left that cap loose, that rotor button going around could cause damage that I didn't need to have. Oh, and of course we always know Sharpies like to dry out if you leave the cap off. So I'll put my cap back on my Sharpie. And here goes. And that's telling me that's only like 60 pounds. All right. 60 pounds. Hang tight. We'll do another cylinder. I'm sorry, yeah, 60. All right, I'm back. I'm on the driver's side bank now. I'm just testing one cylinder over here. Get my remote start. And that as well says around 60. Now, just to be a little bit of a party pooper here, I've already compression tested 5 cylinders. And a little tip for you here. If it's a bone cold motor, then spray something inside the cylinder that's oil-ish, you know, penetrating oil, WD-40, and then do your compression test. What it'll do is lubricate your cylinder, especially on a bone cold motor. They don't make good compression numbers when they're real cold. They have to be warm. A lot of your compression testing will be self-curing once the engine starts and oil starts to get getting slung everywhere. It'll help seal up all the imperfections in each cylinder and on your pistons, and you'll get a little bit better numbers on a warm motor than you will a cold one. So in this case, I already pre-oiled and pre-tested cylinder 1, 2, and 1, 2, and 3, and then 5 and 6, and I come up with 90, 60, 90, 90, 90, 90. That was a cold motor, but each time I sprayed lubricant in there. I don't know why I was holding 60 on number 2 over here, so I won't forget that. I'll revisit that. All right, so with that test complete, there's one more thing you can do during your troubleshooting with very little expense that gives you a whole bunch of new information. So hang tight. All right, one of the things that we haven't talked about is how do I confirm my computer's working? Well, your computer does a lot of things, but think about the basic things that it does for your situation. Like in my case, I know my 5 volts is being developed by the computer, so I could go to the, I believe it's the orange wire, not the black. One of these wires on the throttle position sensor will have 5 volts on it. It's the, yeah, it's the orange wire. I'll have 5 volts here. As soon as I turn my key forward, I should have 5 volts. That's the computer sending out 5 volts. It's got a 12-volt battery. It conditions it and sends out 5 volts to things like your map sensor, your throttle position sensor, your... so I know I have 5-volt circuitry, so I know my computer's doing its job. One thing that we don't know is, are the injectors pulsing as they should with respect to the rotor button turning? I won't make you watch this, but I have a little tool here I made out of a piece of sheet metal that just basically slips over the fuel injector connector, allows me to pull. It undoes both clips on the fuel injector connector. I'm not even on screen. It's just a piece of metal that slips over the fuel injector and grabs a hold of the clips and allows me to disconnect the injector without breaking the tabs. So hang tight while I do that, because I'm going to disconnect the injector and show you a way that to verify the computer is doing a job and it's not another fault. Okay, so here's a random little light bulb in a socket. And what I'm going to do is plug this into the fuel injector connector. Just like that. And the other one like that. Let me verify we got a decent connection at least. Should have something that's good enough. We're looking for a blinking light. Hopefully this works. I'll turn out some lights. And for this I have to turn the key forward. And I don't think I need to have the S connector connected on the starter relay. What we're looking for is the computer signaling the fuel injector to pulse. And we're clear, yeah. Now that's some quick strobing. That looked like a solid light to you probably, but I'm in this general area right here. Let me see how you guys can see. It's pretty dark, but hopefully you saw a little light there. I think I want to kill this other light too that's above me. Let me see if I can do that. Yeah, I want to turn that off. See if you guys can see that. I'll zoom you in a little bit. See if that changes anything. Yeah, you can barely make out a little light. Zoom in a little bit more. There we go. Yeah, you can see that on your right hand side of your screen. All right. Let's talk about that. Hang on. Alrighty, let me unzoom you guys and we'll wrap this video up. And I can tell you what I got to do. Alright, so what that told us was the computer is getting a command from something and causing that little light to blink. It is pulse width modulating the fuel injector. It is sending power. No, the computer doesn't send power in this car. All the injectors are hot at all times with the key forward, and the computer switches the ground signal. That's the least intrusive on the computer. If it's switching a ground, it's not under the brutalness of the hot leg all the time. So this told me that my computer is in the game and functioning and doing a job. So therefore, everything I just troubleshot told me I'm 100% sure this engine, the timing chain is too stretched because of the high miles, and I slipped a tooth, and therefore here's what I got to do. I must take you guys down and off of this. Alright, so what I got to do is I'm going to remove that header panel and bumper cover. I'm going to, one more thing. Yeah, so it's always good to have more information, right? Check the condition of your coolant. You don't know what's going on. Yeah, there's so much you can do. Let me get a light. There's another interesting test to verify head gasketry. Let's see if I can balance that right there. And watch the coolant as I pull the trigger here. Okay, you see that? That's a good sign, because if, as you crank the engine, if you saw air bubbles burbling through as you were cranking, you would know you have a likelihood of a blown head gasket, or a cracked block of some sort, or something like that, a minor crack that only shows up when the engine warms up. So there's more information. So I've got green looking fluid that looks okay. I didn't see any problems with that fluid. Where'd my radiator cap go? You can check your oil and see if you have foam on it. If you have like a foamy looking substance with a little bit of water bubbles stuck to your dipstick, that's more information. So I'll just pull my dipstick out here and we'll check her out and see. And I don't see a single sign of any kind of water bubbles. It just looks like it needs an oil change, right? We'll leave that laying over here for now. So what did we find? We found that I've jumped time. My timing chain is stretched. I got to take the header panel and bumper cover off and the bumper. And then I'll remove the radiator. And I can begin working on disassembling the accessory brackets on the front of the motor to get it out of the way so that I can get my timing cover off. So, let the fun begin. The video's been more than long enough, but that's where I'm at. I need to remove my timing cover. On Ford, this is not a job anybody who owns a 302 wants to do, because those bolts that hold the timing cover on are like anywhere from 4 to 5 and 6 inches long, and they're real skinny. And lots of times they'll be corroded in such a way, as soon as you break them loose, they break. So I'm getting ready to go down a path of high risk here. If I break bolts off, replacing this timing cover, or taking the timing cover off, I have to fix it. It's my car. This is a daily driver for 370 some thousand miles. Let me see if I can find an old timing cover. Yeah, so I found a timing cover over here. This is the part I'm after. This thing. Right here. It sits on the front of the engine. Yeah, that's the correct side. So there's the timing cover that I need to remove, but it's held on by some pretty lengthy bolts everywhere. And it's not going to be fun. It's just high risk, no matter how you dice it. Okay, guys, well, what took me 20 minutes to troubleshoot myself took about an hour to explain. But again, when you run into a problem, start learning the basics. Do I have fuel? Do I have spark? Do I have air? One of those three things generally is going to be missing. Now, in a newer car, the likelihood of that being true all the time is growing slimmer by the year, depending on how they want to engineer these cars and continue down the path of going overboard. I just don't recommend buying a brand damn new car anymore. Google YouTube, look up on YouTube the $5,300 tail lamp on a Ford pickup truck. I think it was $5,300 tail lamp, and that'll explain what I'm talking about. These things have computers inside the tail lamps. There's CAN bus communications and heat sinks and a control module built into the tail lamp assembly. And it's overcomplicating simple stuff is what it really boils down to. All right, guys. That's my mission. Next time you see me, I'll have the header panel off and I'll have the radiator out. I may let you join in on that. I don't know. But all that's going to be really easy to remove because this header panel has been replaced a couple of times. I've been in here before. This vehicle has been in a couple of fender benders with deer and always been fixed. Yeah, I've got lots of spare parts to keep this thing going. Hopefully, my journey through the timing cover goes well. Wish me luck. See ya. Bye.